In this example, I'm going to show you how to solve nonlinear systems of equation. So to do that, let's try to solve this example. I have a system. I have the equation x squared plus y squared equal to 25 and 3x minus 4y equal to 0. So I named this equation 1 and this equation 2. I see that equation 1 is the equation of a circle with the radius phi, and this is equation 2 is the equation of parabola. Even gives me is a straight line. Right? So equation is 2 is a straight line. The first one is a circle. Now I see that our system have one linear, this is linear equation, and one non-linear. So the best way to solve for this system is using substitution method. And this method is say, well, I want to rewrite one of the equation such that one variable equal to other variable. So, and to do that, I see that equation 2 is actually easy to solve for either x or y. So I'm going to use the equation 2 to solve for x in terms of y. So I copy the equation 2 down. Now to solve for x, I'm going to plus 4y both sides. And then divide by 3. You can solve for y too if you'd like, but I see it's easy to solve for x because all I have to do is move the 4y to the other side. So this is what I need to substitute this variable back to the equation 1. Since I already used the equation 2 to rewrite as x in terms of y, now I'm going to use this to substitute inside equation 1, not 2, because I already used equation 2. So now I have to use equation 1. So now I substitute this inside equation 1. So let me you read x is 4 over 3y squared. That is x squared plus y squared equal to 25. This 4 over 3 square mean 4 over 3 times 4 over 3. So I have 16 over 9 y squared plus y squared equal to 25. And these two here are like terms, so we can add them together. So our LCD here is 9, so I put 1 here, so I times 9 here, times 9 here, so I have 16 over 9 y squared plus 9 over 9 y squared equal to 25. I'm going to add it two together, and we have 25 over 9 y squared equal to 25. Okay, 16 plus 9 is 25, and I keep my common denominator. Now I'm going to solve for y. To solve for y, I need to cancel out this number in the front. So to do that, I'm going to multiply by the reciprocal of 25 over 9 is 9 over 25 to the both sides of the equation. So you see 9 here cancel out, 25 cancel out. So now I have y squared equal to 9. Take a square root of this and that. So y equal to plus and minus 3. Because remember the square root, the square here, mean I have two answers for y. So when I take a square root of 9, I need to consider the plus and minus. So now here's our y, so I need to just find the x. To find the x, it's easy. We substitute the y value back to this equation to solve for x. Straightforward. Okay. let's do that. So now if we use y equals to 3, then I put 3 inside here, so x equal to 4/3 times y, but y is 3. So now I have equal to 4. Because there's 3 here, cancel out, I have 4. If y is minus 3, then I will have 4/3 times y, but y now is minus 3, so I have minus 4 for x. So our solution, our answer should be, I have two answers. One is when y is 3, y is 4, so 4, 3, and minus 4, minus 3. This is two answers for the problem. You can always check your answer. If you like to check your answer, then you need to take this solution here and substitute back to our equation from here. And if both of them, the statement of both of them come out true, then our solution is correct. I know our solution is correct, so I won't check it. So I leave it for you to check the answer. So let's try an next example. Next example, I have a system, which is I want to solve for the system x squared equal to y squared. Well, guess me what I'm saying. X squared plus y squared equal to 13, and x squared minus y equal to 7. Once again, I like to name my equation. I see that my first equation is a circle with a radius of 13, and my second equation is a parabola. Now I see that both of my equation, and they are both non-linear because the square here in the x and y, it tells me this is non-linear. Since our system have two equations and all of them are non-linear, so the best way, well, not the best way, but most preferred way to do is we use addition method, or this method here also go by name of elimination method. It's the same thing. I like to call it addition, but your auto is called different name, but the same thing. So we use elimination method, or also called addition. Now the whole idea of this is I want to add these two equations in such a way that either x or y cancel out. If x cancel out, then we have y left and we can solve for y. If y cancel out, then we have x left over and we solve for x. But either way, the answer is the same. Now I'm going to cancel the x squared out because I see it's easier. Because you see the first equation and the second equation both have x squared. The only way I can cancel it out is one of them have minus in the front. If one of them have minus in the front, when I add, they all cancel out. So to do that, to accomplish that, first I'm going to multiply this equation number 2 by minus 1, or you can multiply equation 1 by another 1 too. Either or, but not both. You can multiply equation 1 by minus 1, or you can multiply equation 2 by minus 1. So I decided to multiply by minus 1 by 2 to the equation 2. So let me rewrite this equation. This system again. So now we have minus x squared plus y equal to minus 7. Now when I add this, the x term disappear. Oops. Then for I left a y left over, so I have y squared plus y equal to 6. Okay. Now I see that we have a quadratic equation in y, and we can solve for this by factoring. So to do that, I'm going to minus 6. Both sides get a 0. Then I'm going to factor out. This minus here tell me I have two opposite signs. 6 is 6 and 1, 2 and 3. So I'm going to pick 2 and 3. So I have y equal to minus 3 or y equal to 2. This is two answer for y. So now to solve for x, I'm going to go back to our problem and solve for x. You can use either the first equation or the second equation. I'm going to use the second equation because it's easier than the first equation. Look nicer. So if y equal to minus 3 to solve for x, I'm going to have, let's see, I'm going to copy down my second equation, which is x squared minus y equals 7. So I'm going to substitute the y, which is minus 3. So I have x squared plus 3 equal to 7. To solve for x, I minus 3 both sides. Then I have x squared equal to 4. Take the square root both sides. So x squared, therefore x equal to plus or minus 2. So now where I have two solutions when x equal when y equal to minus 3. So I have 2 comma minus 3 and minus 2 comma minus 3. This my first two solutions. Alright, and over here, if y equal to 2, I'm going to substitute the value of y inside my second equation to solve for y. So I actually have, it seems like I have 4 possibilities for my solution. So we have x squared minus 2 equal to 7. To solve for x, I plus 2 both sides. I have x squared equal to 9. The square root both sides. X squared the x squared with the square root cancel out, so I have x. So now I have 3. So now I have two solutions of x also. So this means I have when y equal to 2, I have 3 for x and 2 for y, and minus 3 for x and 2 for y. So I have another 2 solutions. So totally I have 4 solutions for this problem. If you like to check by hand, then you have to check each of these solutions by put it back inside our system and make sure that it's true. Now I'm going to do is I'm going to check this by graph. So I check the solution by graph. So I'm using the program. It's called GeoGebra. It's a free program you can download from the website. You can go to www.geogebra.org and download them straight. So I'm going to graph my systems. Remember that I told you the equation of 1 is a circle and the equation of 2 is a parabola. So let's try that. So I did it. I mark. I see that my system, the equation number 1 is a circle with the at the center 0 and 0, with our radius is the square root of 13. So I plot the center for a circle. So here's how I graph my solution, my system. I have a circle, the radius, and then here is my parabola, and then I'm using the intersection between the two objects here, and it gave me 4 points. This 4 point is the common point of two graphs. So therefore, this 4 point here is the solution of our problem. Exactly what I got when I saw using the algebra method. And here's how we graphed. If you want to graph to solve your problem, then it's how you do. You first have to graph the circle, and you graph the parabola, and the intersection between the two graphs. Those are our solution. In this case, is clearly I have 4 solutions, and they are exactly what I have when I solve for the problem by using algebra. So that's confirmed that my solution is correct.